about let's get started? Okay. My name is Pat Murphy. I'm from the Biological and Agricultural Engineering Department, kind of the engineering side of the swine team. This afternoon we're going to stay away from diarrhea if we can. Oh no, you saw me sitting over here. I was sitting over here with Dr. Ralph Richardson, our Dean of Veterinary Medicine, and I moved over and put a chair between us. I don't know about that stuff, but we got different stuff to talk about this afternoon. First up is we're going to have Dr. Nelson inform us about the potential to improve the survivability of low birth weight pigs. And those only occur at the university?
A little more than that.
A little more than that, and we're going to realize full value with a full-size pig somehow. Dr. Nelson's up.
Thank you, Pat. How was lunch? Lois done another great job, yeah. I think the record was 4 chops. I'm not going to point out any one individual, but it was another good day for pork consumption in Kansas. A lot of people ask me at my table how things are going to come out tonight. Take K-State. We're going to win by 7. So just so you know, I'm going to make that right now the official prediction. We put together a team, and Pat introduced it, looking at low birth weight pigs and their survivability in production units. And really for the last 3 or 4 years, this became a really, really hot topic as we continue to get larger litter sizes. We went from 9 pigs to 11, 12, 13, 14, 15, 16, 17, 18 born alive. And we thought, that we are going to target an area in our industry where we're creating a lot of variation. And Pat talked about the full value pigs in the introduction, and yet all of a sudden this PED hit. And so we thought we had the targeted area for research at Kansas State that was going to be really hot, and I think it'll come back. I really do over time as we save more of these litters, but really our targeted animal within our team here that we've been working on this research project is these particular pigs that are just lighter at birth, usually less than 2.2 kilos. And we do a lot of visiting with other researchers across the country. Purdue University is the other university that spent a lot of time looking at this, but they've looked at it from the genetic side, okay? And what they studied in the Purdue data is if you compare 2 pigs, this one and this one, in commercial operations, not just K-State, Pat, but in commercial operations, this little pig that weighs less than 2.2 kilograms at birth, by the time he goes through the nursery, if he survives farrowing, as he goes through the nursery and grow finish, that pig is worth $20 less per pig compared to its counterpart, not the big pig, but the pig that weighs greater than 2.3 pounds at birth. And so again, when we met as a group, we started analyzing this and studying and say, this is a real opportunity, not only from nutrition, but reproductive physiology and muscle biology, as we'll learn this afternoon. And so we set out to put together a team, and it was really interesting. Shortly before this time, we'd hired a new president at Kansas State University. And he had said in his review, he traveled the state, as all good administrators do, got to know what the issues were, ask our clientele, what's K-State noted for? Animal science was undergraduate teaching, there was no doubt. #1 by far. And matter of fact, in a recent interview that he did with the Collegian, he ranked us as one of the top 5 undergraduate schools for all of agriculture in the U.S. Where we were missing and where our president picked up on was the innovation research. And so Dr. Schultz, about this same time, put together a program called Research for 2025. Have you heard about that program? Yeah, you have. It's on all the football post-game shows. You hear it all the time. And so we decided that K-State needed to change things a little bit, and so it's a little more challenging to us, but we tried to move away from what we call refinement research and marketing research and try to work in an area that actually Dr. DePietri talked about as well, is innovation. And it's tough, especially as somebody that's been doing applied research for their entire career. As you move up that pyramid in terms of research, the risk is much higher. We hope the rewards are equally as good. The other thing is we use this hourglass to reflect what Dr. Odie pointed out this morning is we're under some time pressure here. Every speaker that I hear anymore that gives a lead off talks about feeding the world's population and whatever. They all pick 2050. But obviously the population is growing. We're worried about world hunger. And so what we see in animal agriculture and what K-State's been pointed as having to improve is new concepts, new innovations in terms of technologies and application in the swine industry. And we thought this lightweight pig, full value pig, fit right within the targets of the university. So we put together a large team, and I wanted to picture these people. We're proud of all our graduate students at Kansas State University, but this group that is developing technologies and management strategy and new basic research, the basic research and fundamental research side of this is really making some progress. And I want to congratulate all those students that chose this field. I know it's extremely tedious research. Quite frankly, I probably couldn't do it, but you guys are doing a great job and you're getting trained very well. And what I'm proud of today is when you talk to other universities, we're starting to have an impact in terms of having our PhD students hired, which is another challenge that our presidents gave, more PhD researchers cranked out by the university. We have Chad Polk back today. I don't know if Chad came back in the room. That was one of the first people in this team. Worked closely with Dr. Gonzalez, now at Texas A&M University. Where's Darius? I lost track of you. Darius, back here, postdoc, working in the same group, just got the offer from Mississippi State University. Chad, I guess they play more than just football down there. They do a little research too, huh? So we're proud of these students that are coming through here, and I think as we move towards understanding technologies that are innovative, these young people are going to have a lot of opportunities. Okay, other meetings that I go to all the time, again, fulfilling my extension role, people say, what have been the big changes in the swine industry the last 20 years? You can rank these differently. The people that I work with in research circles say there's no doubt genetics has been the biggest change. Number of pigs born alive, litter size at weaning, feed efficiency, growth finish that these guys will talk about later. I think the whole morning basically covered number two. DePietri mentioned the export markets, but if you come down this list, nutrition has fell behind, but the one that's really lagging in animal agriculture is new technologies. And if you look, it's ironic, if you look across the country, the plant side is really smoking us. And I'll give you an illustration. It's after lunch. The animal side of new application research are really new technologies versus the plant. You could equate that to the animal side being KU the other night and the plant side being Kentucky. I mean, anybody who's seen that game, it's a big gap. And the reason for that, quite frankly, is research funding. And so as we move forward, we got to find new ways to fund research on the animal side that'll keep our industry moving forward and meet the needs of a world population that's growing at a fast rate. So this is what we've seen. A matter of fact, this is actual data out of a publication from Purdue. We've seen in the last 10 years a marked increase in pigs per sow per year. Now these are averages. I know there'll be people in the room say, well, I got herds doing 33, 34. But really in just 10 years, pigs per sow per year has went up roughly 8 to 10 pigs per sow. The research technology that's out there on the genetic side, they tell me that with continued selection for a single trait, litter size, that will be within another 10 years, we'll have herds hitting 40 pigs per sow per year if we can manage the pigs. Okay? The challenges with those larger litters, and I mentioned this earlier, as we continue to select for larger litter sizes, you get increased number of lightweight birth weight pigs, and again, Dwayne's going to address the uterine capacity. Dr. Gonzalez is going to talk about the muscle fiber number, but this is out of the Purdue distribution, a normal distribution for number of pigs born alive, or birth weight, and as we increase number of pigs born alive, we're getting a non-normally distributed population where a lot of pigs are less than 2 pounds at birth. Matter of fact, the new genetics that we're switching with at K-State, when they came in and presented their information, they said you better be ready for 15 pigs born alive, and 6 to 8% of those pigs weighing less than 2 pounds at birth. And we got to figure out ways to manage and keep those in production, and again, try to realize full value at the end. Okay, the other thing that happens is not only are these pigs, the survivability lower in the farrowing house, but if you look, they're slower growing, they're less feed efficient, they have reduced lean gain. But what I think is even more challenging and what we're going to face in the future is we take the lighter birth weight pigs versus the medium to heavy birth weight pigs. I think it's going to become an animal welfare issue. I really do. When we're getting so many pigs, and we publish in National Hog Farmer, and I know those are great magazines, but we start talking about people, and we're having these survivability rates are dropping off. 24/7 management if our in-house tried to survive, have more pigs survive. I think it'll become an animal well-being and animal welfare issue as we move forward in the industry. So what have we been working on, and I'm going to turn this over to Dwayne in just a minute, is an area that we think is imperative in this whole model is the whole idea of fetal programming. This is not new to us in terms of a concept in the animal industry, but what fetal programming is a uterine environment program change physiologically that changes that animal throughout his life. That piglet that's born at a very early age, we have done something during gestation, during the pregnancy period, that changes the ultimate outcome of that piglet as he approaches the weaning phase, the grow finish phase, and ultimate carcass quality that pig is determined. And so with that, and I think this is one that actually Darius made the slide and I liked it, and so I asked him to put it in our presentation, is most of our people in production, at least the people that I work with over time, spend a lot of time in lactation figuring out how can we save those lightweight birth weight pigs, and we're going to talk about that a little bit later. And today we talked about nursery situations with some of the disease challenges. But if you look at the opportunity where from conception to final product, where we have opportunities in modern production to influence the outcome of our product, 39% of that pig's life is spent during pregnancy, which is actually equal to what the group's going to spend a lot of time later talking about the grow finish area in terms of nutrition. So we have a huge opportunity. And so that's the setup I wanted to give you today. What I feel good about is we have a good team. Dr. Davis, a reproductive physiologist that many of you have known for some time at Kansas State University, has really helped us with this. And Dwayne, I think the thing I'm most proud about what you've done is not only for our research, but in our curriculum in animal science, in faculty meetings where some of us don't have teaching appointments, Dwayne sits there and really emphasizes putting the science back in animal science. And so with that, Dwayne, I'm going to turn it over to you and look forward to your presentation.
Thanks, Jim. I really thought you were sleeping in those faculty meetings. Glad you picked up on something, but that wasn't me. That was somebody else. So again, the whole area of fetal programming is one that you probably hear a lot about anymore. So in a way, now the swine industry is getting into the position of having more and bigger litters and more of those pigs that we have a challenge making full market value pigs out of. We do have some information to draw on. It's kind of interesting that fetal programming is something that seems to affect all mammals. And you've got to really wonder why that's there, and that's part of what some of the debate is in the basic literature. But as far as pigs, we know that it is affecting the way they utilize their diets, so it's affecting all these things. Pigs that are placed under stress, under nutritional stress, due to placental insufficiency during pregnancy, are in fact changing the way they partition nutrients, changing the lean growth towards more adipose tissue, putting more of those nutrients into fat cells and the things that don't have very much value for us in the swine industry. It also affects the disease susceptibility of those offspring when they're born, if they survive, as Jim said, and if these are multipliers producing females or boars to go into boar studs, it does affect their reproduction. And we may think we don't really keep those to reproduce, but probably there's effects on the other animals in those litters, I think, due to the competition that's being set up in these really large litters. And of course, these are production costs, all of them. So how does that happen in pigs? It happens in all mammals. Anytime that you place a stress on the fetus at certain stages of pregnancy, perhaps any stage of pregnancy, and the stress comes about because of how much of maternal nutrients that they can transfer through their placenta to those developing piglets. And that turns out to be a bigger and bigger deal the more that you place in the uterus. So in pigs, where our maternal genetics that Jim mentioned has done a real good job of increasing ovulation rates so that we can actually challenge the uterus and produce more pigs all the time. But we've found good ways to get lots of eggs fertilized, bear lots of little happy embryos to start out with, and they move the uterus pretty early, and then by around day 12, 10 to 12, they distribute throughout the uterus, but they don't do it evenly. And in just about a 2 or 3 hour period, sometime on day 12, they elongate. And they don't all get the same space because they don't overlap. What they're really doing is dividing up the space in the uterus, and sharing isn't something they're programmed to do. That's not a part of fetal programming. So obviously, anything that's in competition, the more space you get, the more space in the uterus, the bigger your placenta is. One of the first things they do after that is attach and start to increase uterine blood flow, so they've got an environment set up for the placenta. Placentas grow, and then fetuses grow. And this is where we start to see the challenges come in. Sometime after day 25 to 30, the amount of space that that particular embryo got is going to start showing up as far as its size. So here's another way to look at it. Here's a sow's reproductive tract with one horn elongated. So when they elongate, they don't overlap. Space isn't allocated equally. Some get more and some get less. Here's some data we collected on, this is actually just fetuses at day 60 from 8 gilts. So we slaughtered the gilts on day 60, and then we took several measurements. You can actually measure, I didn't mean to go quite that quick, we can actually measure their attachment length, and that few hours on day 12 set them up to have either a short or a long distance in there. And there's some in the middle, of course. And that correlates pretty well with their weight. Not maybe too surprising there. Another interesting thing is that if you devise a way to measure their efficiency that they're utilizing that space, and here we've again got attachment length that they have in the uterus, so that matches this distance over here, but now take their weight and divide it by the attachment length. So that's how efficiently they're utilizing the space. Maybe there's some good news here because it says they've got some potential to get more out of uterine space than the ones with a whole lot of room get. Okay? When you restrict them, they have the ability to increase their efficiency of transferring nutrients from mom's blood into that fetus. And so they do better than you might think they would down here with just a little bit of space. But a lot of these down here we're going to lose before farrowing. But there are some of those that are going to be those really small pigs that Jim was pointing out. And they're the ones that we have challenges with. I just pointed out here are 2 fetuses that each weighed 110 grams. Now, one of them has a little less than 100 millimeters of space and the other one over 150. And I actually did the math. The one with the less space is actually 1.8 times as efficient. If we could figure out a way to improve the efficiency even more, we might be able to do something here. And that's one of the things we're interested in working on. One of the reasons this is important is it's not just the size of the fetus, it's the organs in that fetus that are all also competing for nutrients. So the brain here, again, probably no surprise that bigger fetuses have bigger brains. You might think that would happen. The liver, bigger fetuses have bigger liver. And notice that the slope on that is a lot steeper. Okay? So the liver is growing pretty rapidly there, and the liver is pretty important. You've got to have a good liver to have a good pig, to have a full value pig. And at this stage of pregnancy, that's actually where blood cells are being made. So think the cardiovascular system, the immune system, and all those kinds of things. So bigger pigs have bigger livers. That's not a winter. There we go. So again, do another calculation. If you take brain weight as a percent of liver weight. Okay? This is a standard way to show what's going on in the challenged fetuses because it's brain sparing that's operating. The brain has priority. So when the brain is challenged for nutrients, it has first priority. That means that when nutrients are restricted, the liver and the other organs have to make do with less, and they're not going to do so well, obviously. So the pig's going to try to keep its brain growing as best it can, and then it's going to challenge the rest, not just the liver, all the other tissues. Dr. Gonzalez is going to talk about muscle in a little bit. that's another one that suffers. Here's some data from John Bergstrom's thesis. John, you recognize that? Is he in here? Yeah? Okay, you tell me if I get this wrong. This is one data set that he had on 418 pigs that he followed from birth to market. And so what he's got here are the individual birth weights put into categories here as kilograms and separated gilts and barrows. And then this is their back fat at market weight, at slaughter. Actually, these down here, as I looked at John's data, they didn't quite get as what we'd say is full market weight, but they got as close as he could get them, and they were still fatter. And so you can see gilts, those that were heavier at birth, had more fat when they were slaughtered. And same thing with the barrows. Okay? And so what I've headlined this up here is uterine capacity is limited, and the in utero environment is programming these fetuses. And one of the big debates about this in general, about fetal programming, is are these just irreparably damaged, or is this an adaptation? And one of the real ideas is that in humans, and probably in other species, the fetus is reading what the environment's like to be when it's born. So if it thinks it's going to be born into a world, and I'm saying its physiology is adapting here, it obviously isn't thinking this through, but if it's expecting, its physiology is expecting a challenging, short supply of nutrients after it's born, then it's going to think, well, so we better put a lot of the nutrients that we do get into fat, store them, because times are going to be tough. And that's what these guys do. So what I did then was to convert these to pounds and take a midpoint. And so if you take here the middle, about a 3.5 pound would be a pretty nice pig if they all weighed that. I think we'd all think that was pretty great. And they do pretty good. Now, there is still some room to improve on the barrows in these data. But notice what happens when you get less than that. Back fat really goes up. So that's the setup then to turn this over to Dr. Gonzalez to tell us about muscle biology and what's going on in pregnancy. I'd say many of you haven't had a chance to meet John yet. He came to us in 2011 he was finishing his program and his postdoc at the University of Florida. If you're ever in Weber Hall and you go into the Don Good edition, go clear to the top and then go as far north as you can go, and that's where John works. And he keeps these grad students kind of corralled back there so they get a lot done. But that's now called the Meat Chemistry Muscle Biology Lab. Did I get the sequence? Okay, he corrects me if I don't have that right. But anyway, he's put a lot of effort. He's been here since 2011. He's put a lot of effort into getting that lab going, and he can do some really neat things. We're going to turn it over to him.
Thank you, Dwayne. I was wondering if he was going to say some nice things about me. So, thank you very much. Pleasure to be here and talk to everybody. My first time at Swine Day, presenting at least. I usually come for the lunch and the talks. So as Dwayne said, there's order of importance in fetal development for certain tissues. And muscle, I would say, is third on the list. Of course, your organs, your brain are number one. Your skeletal system will be number two, and then muscle will come in third. And then after that, you'll get fat development. Before I go any further and talk about some of the measures that we take and how we compare a small and a large animal muscularly, I want to orient everybody or kind of familiarize everybody with the structure of muscle tissue. So if you look here, you have your whole muscle, which the equivalent would be the pork chop we had in the plate in front of us. That is a cross-section of that muscle. It isn't comprised of muscle fiber bundles here, as you can denote here. Muscle fiber bundles are then reduced or are composed of the actual cellular unit of muscle, which would be the muscle fiber. And I just got done teaching this to Evan Tigmeyer's class. In order to kind of quantify how big a muscle will get, I use this for students and say this is our muscle mass equation. So it's an easy equation where ultimate muscle mass equals muscle cell numbers plus the enlargement of those muscle cells. Now the problem with this is, in mammals at least, is that muscle cell number is determined during gestation. After gestation, you're not able to get any more muscle cells. And so all you can have after parturition and postnatal growth is cell enlargement or making those muscle fibers bigger. And so I like to tell the students, a little wimpy guy like me probably has not very many muscle cells, and they're not very big, I'll tell you that much. I always wanted to biopsy myself, but I'm kind of scared of the pain. Now, we'll use Dr. Nelson as our Arnold Schwarzenegger of the group, and he has a lot of muscle cells, and they're very big. And so that's kind of the difference between us. You know, this 14-inch, square-inch loini that we came off a Chad Pock study, this guy has a lot of muscle cells, and they're very big too. And so as far as when this occurs in gestation, it occurs at two different stages. And so that would be primary myogenesis, denoted here, and secondary myogenesis, or muscle fiber formation. And so primary myogenesis occurs around day 25, extends to anywhere from day 50 to day 60. It goes from the embryonic stage to the fetal stage of development. And so with that, you have formation of primary muscle fibers. And the importance of these guys are they serve as the scaffolding to what is going to occur or what's going to be formed during secondary myogenesis. And we actually just generated some data, and we've seen some published data, where for every one primary fiber that's formed, you can go anywhere depending on what muscle you look at. You can see anywhere from 7, 16 to 41 when we saw in one muscle, secondary muscle fibers formed. And so it's a good correlation with how many are formed here will determine how many are formed during secondary myogenesis. And so once again, like I said earlier, you're not able to form any more. So this part of gestation of swine from day about 25 all the way to day 90, because secondary myogenesis goes from about day 60 to day 90, that's probably the most important time for muscle development and ultimately what you're going to be able to sell at the packing plant if you're going on a muscle basis. After you have primary and secondary muscle fiber development, you then have just enlargement of those muscle cells. And then if you have these actually scaled back, like Dwayne just got done saying, you'll see adipogenesis kind of gets shipped back on here, and that's what results in having pigs that are fattier later on in life. And so our question when Dr. Nelson and Dwayne came to us was, what are the muscle differences between a large and a small fetus? So we took these two guys, a small pig here and a large pig here, and looked at their muscle fiber distribution, their sizes, and determined what the differences were between them. And so it's from the same data set that Dr. Davis just got done talking about. We took 8 pigs. We took the small, the medium, and the large animal. And what we ended up doing was taking their longissimus muscle, or the loin muscle, cutting it in half, and then blotting it on a piece of paper, because they're kind of hard to quantify how big they are, because their muscles at day 60 of gestation is very slimy, I guess is an easy way of putting it. And so we used that to measure the cross-sectional area of that muscle. We then embedded the muscle into a freezing medium, cut razor-thin sections, and then used a microscope to visualize the individual muscle fibers, which I'll show you some pictures here. And so here's how we actually quantify the actual muscle fibers and analyze them. And so I used to do this as a PhD. Everybody next to Darius down there, they're pretty much the ones that have partaken in doing this, so that I'll give all the credit to those guys, because I can tell, I will agree with them, it's not fun and it's hard work. So we do a three stain method, where we look here, and this is a DAPI, or a Hoax stain, and what that does is that stain will bind to DNA. And so it identifies any nuclei. We use that as an index of these nuclei will have to fuse with each other or join up to form a muscle fiber. So we use that as an index to say, okay, so these guys have more possibility of generating more muscle fibers. We then have this red dye, which is a dystrophin dye, and that is just used to identify the periphery of a muscle fiber. And so we use that in our cross-sectional area measurements to say this is how big the muscle fiber is. And then in our final stain we have here, it is I like it, it's called BAD5. But in adult skeletal muscle, it identifies type 1 muscle fibers, but in fetuses and neonates, it'll actually detect primary muscle fibers. So we're actually using these to identify primary muscle fibers. And so when you combine these pictures together, what you end up finding are you have these positive, big primary muscle fibers, and then if you look right here at these guys, they look like gummy bears a little bit, but they're negative for that stain. those are the beginning of secondary muscle fibers that are being formed. And so we count the number that are associated with that one fiber and use that as an index. And so what did the data tell us? And remember, these are 60-day fetuses that we took from these sows. For the rest of the talk, you have the smalls, or the fetus size, the smalls right there, and then you go to medium and large, and that'll be the same through my next 4 slides. And then for this one, this is our cross-sectional area of the entire muscle, so what Matt blotted on a piece of paper. So just, there was a significant size difference, where the smalls were 13% smaller than the medium, their cross-sectional area, and the larges were 21% greater than the smalls. And so that would make sense because you have a smaller pig, it has less muscle in there. And so that's kind of cool that we saw there. Now we actually counted the primary fiber number, or those that were actually yellow or orange in color. This is the total number in thousands. And so what you end up finding here is we also find the size difference. But the cool thing about this is the medium pigs have 12% more primary muscle fibers than the small animals. So that would account for that 13% enlargement in the whole muscle area. Now for the larges, this is only 13% more than the smalls. So you still have about, if you go on the 21%, you have about 8% more to make up. So what's the difference? Why are the larges different than that when you look at the whole muscle? And so you would think, well, maybe those muscle fibers are bigger. So we looked at the cross-sectional area of the primary muscle fibers, and there were no differences in small, medium, and large animals. And so you would say, okay, so now why are the larges 21% bigger than the small when you look at whole muscle? And so what we ended up doing was making a ratio and counting the number of secondary fibers to primary fibers, which we have there on the y-axis. And so there's no difference between the mediums and the smalls, but the larges, if you compare them to the smalls, have 9% more secondary fibers formed than the small animals, and so that would kind of make up your difference to get your 21%. So overall take-home message is the difference in muscle, at least in the loin, between a small and a medium animal lies in the number of primary muscle fibers. The difference between a large and a small is that the large also has more primary muscle fibers, but they also have more secondary fibers formed at day 60 of gestation. And so our question as a group is, can we manipulate the small to develop more like the medium in gestation? That would be nice. But also, Dr. Burnett and I, even though he's leaving my lab, we've also thrown around ideas, once these little guys are born, could there be countermeasures or interventions to not make more muscle fibers, but at least have them grow as efficiently, or at least survive the first few weeks of time in the nursery? And so that's kind of some of the stuff that we're throwing around in my lab. And so with that, I'll turn it over to you, Jim.
Thank you, Dr. Gonzalez. I got to tell one more faculty meeting story. You said I was sleeping? Actually, no, it's not about that, Dwayne. It's actually, we had one a while back, and with some of the new healthcare changes, we had to sign these time cards that our students didn't work more than 30 hours a week, right, Gonzalez? Well, he and I walked out of the meeting together because we had another research meeting at that time, and Gonzalez asked me, he goes, did Dr. Odie say 30 hours a day or 30 hours a week? And so to the students that are doing this research, it's very intense, but it's also very exciting, as pointed out. And by the way, you need to stay at K-State too. Florida doesn't need you. We have nice, warm winters here in Kansas. So we're glad you're here and stay around. I want to go back to a slide we showed earlier and kind of wrap up with some of the practical things, because at Swine Day we always try to move back towards practicality and once we incorporate the science. And the bottom line is here that there's a number of things that have been tried to change hormonal levels, specifically IGF-1. Way back in the day, Rob Musser did a lot of work for us with carnitine and other technologies that affect fetal programming, potentially during pregnancy. And there's also a tremendous amount of nutritional work that's been done. Bump feeding after day 90, Wayne, a lot of people increase it by 1 kilo. In gilts, it seems to work quite well to increase birth weight, subsequent survivability. So there's some things that are commonly done in modern production system. I know there's probably going to be a study from out of Hordes in Ohio presented this afternoon on lysine by energy levels during gestation, possibly affecting. Sometimes it works, sometimes it doesn't. Vitamin D out of Texas Tech shows increased number of muscle fiber number. So there's also some nutritional ramifications. Some of these you can try in your own production systems when you go home, see if they work. Some of you are already doing that. Some of the larger systems, it's been ironic to me that as they've increased litter size, they're looking, and again, I hate to even bring this up in meetings, but maybe even redesigning the farrowing crate. And I mentioned earlier the whole animal welfare issue, and I hate to even bring crates, either gestation or farrowing crates, up in any audiences, because as we're going to learn this afternoon in the Australian presentation is, you know, once, if crates are gone in gestation, they may be going in farrowing. But again, bigger crates, more room for the piglets, less crushing, chances to get away and provide a better microenvironment. At the Profitability Conference in February, and that sheet is on your chair if you didn't just sit on it or throw it away, I've got Dr. Coleman, or we have Dr. Coleman coming down from Nebraska, and he's really wrote a lot of articles on what you can do post-farrowing, and he's going to address the whole area of 24/7 care. And I read his paper. He actually got snowed out last year, so I had a chance to read his paper, and he's going to come back and present that information. In the farrowing house, there's a tremendous amount that can be done as well. Most of you know these already, but he's saying we need to split shift, have 2 shifts of people, 12-hour shifts in farrowing, to be there when all the pigs are born, make sure they're dried off to prevent hypothermia, get them under heat lamps, provide microenvironments, heat boxes, and then again, make sure they get colostrum. And you know this already. Split suckle pigs, put boxes for the first 6 or 7 pigs are born, put them in boxes, wait for the rest, give them equal chance to get colostrum so they have a better chance of viability. And the Purdue data says it's not a direct correlation between birth weight and survivability. Matter of fact, as I've talked to Dr. Schenkel over the last 2 years, he actually says that many breeding stock companies, including the ones that you use, are now using their selection index day 5 survivability in the farrowing house. What do you think the heritability of that is? Day 5 survivability. At least they're selecting for something other than born alive, so that's a good thing. But what do you think the heritability of that trait is? According to Alan Schenkel, who's one of the leading geneticists, he says it's 0.04, which says 4% of the variation you see in 5-day survivability is due to genetics. 96% of it, 95, 96 is due to the environment which that piglet's born. And so when we try to make genetic selection, even though it's great that we're doing it, it's going to be very, very slow progress to look at survivability of these piglets. Okay, so in summary, it's been a pleasure for us to share this information with you this afternoon. We believe that prenatal development appears to be the rate limiting constraint to reach 40 pigs per sow per year. And it's a really hot area. It's an exciting area for our students. I know they have a lot of fun with it, and when they're in meetings, they're very excited about Dara's new paper that you found out of the UK or Australia or wherever, different people sharing information. It's so exciting. I don't know, did Matt Ritter stay? Is he still here? Where's he at? I got the wrong, Matt Vaughn. Matt Vaughn. Got the wrong Matt. Okay. Matt on his wedding day, which was when? Is your wife here? Good, okay. On that day, no one's supposed to know this, but he went to the research lab and actually worked on fetal muscle number, and then in the afternoon got married. So that's how how excited we are. Also, there's a number of innovative technologies to increase the areas that these gentlemen talked about. And so we're proud of everybody that's interested in this project and all those that work so hard.